let's look at this next example. A 60 kilogram skier with an initial speed of 12 meters per second coasts up a 2.5 meter high rise as shown in the figure. Find her final speed at the top. So they want this final speed at the top, given that the coefficient of friction between her skis and the snow is 0.08. It says, hint, find the distance traveled up the incline. Now, before you freak, grade 12s, realize that this is quite a technical question. It's not an easy question. So let's take it in baby steps, okay? First of all, we know that we have a 60 kilogram skier. She has an initial speed of 12 meters per second, and she coasts up the 2.5, which means there's no other force acting on her other than the force of friction, but the force of gravity. She coasts up here to get up to a height of 2.5 meters with still some velocity. Okay, so therefore we're going to be using the conservation of mechanical energy. We're going to go EP plus EK is equal to EP plus EK. Okay, and this is at the top, the bottom, and this is at the top, plus the work done against friction. In other words, she's taken all the energy she has here and she is converting it to mechanical energy, and she obviously has to overcome the force of friction as well, so she has to do work done against friction. Right, so let's look at the bottom values first. Because she has no height, there's no potential energy, so she just has kinetic energy. So kinetic energy is a half mv squared, which is a half times her mass of 60 kgs times her initial velocity of 12 squared, which becomes, let's work it out, it's 30 times 144, which becomes 4,320 joules. So what that means is this skier has got 4,320 joules to overcome the force of friction, to do work against the force of friction, to get up to a height of 2.5 meters and still have some velocity. So she's going to get up to the height, so she's going to have mass times gravity times height, plus she's going to have some kinetic energy, so half mv squared, plus the work done against the force of friction, so WF. Okay, but now let's talk about this work done against the force of friction, because that there is a little bit of a tricky calculation. So we know that work done is equal to F delta X cos theta. But this is the work done against the force of friction. So this is the force of friction. That is the displacement, how far the force of friction has occurred. And cos theta, because she's going to be traveling parallel to the surface, is going to be the cos of 0, which is 1. So we can ignore that. That's just a 1. Okay. Right, so now we need to look at these two. And they even gave you the hint. They said, find the distance traveled up the incline. So they gave you that hint. So let's look at the drawing. Do you agree that that actually there is a triangle? Okay, that's a triangle. So that there is a triangle. This is 2.5 meters. And this is an angle of 35 degrees. So therefore, if I want this distance here, which is the distance that she basically coasted up, we would be looking at the hypotenuse. And this is the opposite side. So now if we look at SOHCAHTOA, yes, my favorite trig ratios, SOHCAHTOA, we've got the opposite. We want the hypotenuse, so we're going to use sine. So we're going to say sine of 35 degrees equals the opposite, which is 2,5 over the hypotenuse. Therefore, the length, this distance, delta x, is going to be, I need space, let's write it over here. Delta x is going to be equal to 2,5 over sine of 35 degrees and we pop that in our calculator. We got 2.5 divided by sine of 35 degrees. And grade 12s, please make sure your calculator is on degrees and not on radians or anything silly, because otherwise you'll get the wrong answer. So 2.5 divided by sine of 35 is going to be 4.36. So the displacement is 4.36 meters. Okay, so that's the displacement that the force is acting over. 2.5 divided by sine is 35. Yeah, that's right. Okay, now we've worked out delta x. Now we need to work out the force of friction, this force of friction. And for that, we need to draw a free body diagram. Why? I'll show you in a second. So here is a free body diagram. And there's our little skier. And do you agree there's the force of gravity, which is acting on her straight into the ground? Sorry for being not perfectly down. And that there is the normal force. And why am I interested in normal force? Well, because the force of friction, actually I'm going to write it out here. This is equal to the mass, which is 60, times the gravity, which is 9.8, times the height of 2.5, plus a half, times by 60, times the velocity squared that we're trying to find out, plus the force of friction times the displacement of 4.36. And this force of friction is equal to mu k Fn. So we need the normal force. So let's go back to our free body diagram. We know that this is the force of gravity, and it can be broken up into a vertical component and a horizontal component. And this vertical component is equal to the normal force. So this F perpendicular, FG perpendicular, is equal to the normal force. So if we can work that out, then we have Fn. Right. So we know that this angle here is 35 degrees. And we know that this here is mg. Okay, so let's rewrite this thing now. We've got 4320 equals, and to simplify things, I'm just going to put these in the calculator already. So we've got 60 times 9.8 times 2.5, which is 1,470. So it's 1,470 plus half times 60 is 30 Vf squared, plus the force of friction. The force of friction is mu k Fn, which is going to be the mass times the gravity, okay, which is, then it's going to be, this is the adjacent side, and this is the hypotenuse. So if we look over here at the top, that is going to be cos. So it's going to be mg cos of the angle, which is 35 degrees, times by our mu k, which in this case is 0.08, times by the displacement, which is 4.36. I hope you're following that this is F delta x, okay? Force of friction times delta x. The delta x we worked at over here is 4.36 meters. And now the force of friction is mu k times the normal force. So this is here is Fn times the mu k. Right. So now that is equal to 1470 plus 30 Vf squared plus m is 60 times 9.8 times cos of 35 degrees times 0.08 times 4.36. And that gives you 168. So that becomes 168. And that's 4,320. So now all we have to do is solve for our Vf squared. All we have to do is solve for that. Okay. So what we're going to do is we're going to take these and take them across to the other side. So we're going to subtract. So we're going to go 4320 minus 1470 minus 168. And that gives you 2682. So we got 2682 is equal to 30 VF squared. So let's solve for VF squared. What are we going to do? We're going to divide both sides by 30. So if we divide that by 30, we get 89.4. So that's equal to 89,4. But we want the square root of that. So we square root it. And we get 9.46. So the final velocity of the skier at the top of the slope is 9,46 meters per second. And please note they've asked for the final speed, but if they'd asked for the final velocity, you would have had to say forwards or in the same direction. You would have had to give a direction. And that grade 12 is a nice level 4 question on how to use both the conservation of mechanical energy as well as the work done against the force of friction, in other words, your work energy theorem, to solve a very nice question that is a typical exam question. So please, grade 12s, go practice this, go do the question by yourselves, make sure you understand. Have a great day.